Hello, and welcome to this video from the Cambridge Crystallographic Data Center about Cambridge Structural Database Subsets, or CSD subsets for short. I'm a scientific editor at the CCDC, and I would like to share with you different ways to search the CSD and how to get the most out of the database. The CSD was founded in 1965, and since then has grown to over 1 million structures. Every year, we continue to add data from a range of sources, including journal publications, patents, and direct publications as CSD communications. Every single structure in the CSD has gone through a manual curation process to ensure the quality and correctness of the database is maintained. With over 1 million structures in the database, it is important that we provide means for users to interact with and search the CSD. The most fundamental way we do this is by adding additional data such as compound name and 2D diagrams, both of which can be queried in software such as Conquest or online via the web CSD platform. A further way we aim to help you find what you're looking for in the CSD is by creating subsets of data. These are collections of entries that are related in some way, either by a chemical or physical property, or by the data which is available. Subsets have been created based on the perspective the CCDC has built up over the many years of serving the community, and also from the knowledge of external experts. For more information on the criteria with which subsets are created, please see the video description. As a brief introduction, here is the current range of subsets available in the CSD. The list has grown over the years, with the generally recognized as safe, semiconductor, retracted, and raw data DOI subsets being the most recent additions. In this how-to video, I will show you where you can access subsets in Conquest, Mercury, and the Python API, and how you can use them to filter the CSD through a combination of searches. For example, how can we find a polymorph of gabapentin hydrochloride hydrate which features in 3 of the subsets? After opening Conquest, subsets can be directly accessed from the View Databases drop-down menu. Navigating to the subsets in your current CSD version will then show you the list of available subsets. Selecting one of these options will load these entries into Conquest. Here I've selected the drug subset, and we can see over 16,000 structures in the hit list. What if we were interested in drug molecules that are also hydrates? Loading in the hydrate subset and then navigating to the Manage Hit List tab, we can see the list of subsets we have open so far. Here we have various options to combine lists. Updating list B to be the hydrate subset, we can generate a new list of entries common to list A and list B. In completing this combination, we can see that there are 3,429 entries in the drug subset, which are also a form of hydrate. We can click View to inspect the entries found by this search. What if we wanted to know how many entries in the drug subset were both hydrated and also demonstrated polymorphism? For this, we would need to load in the polymorphic subset, navigate back to the Manage Hit List tab, and then use this with our previous result, combination 1. On completing this search, we can see we have 155 entries of hydrated drug molecules which also display polymorphism. If we inspect a new hit list, we can find the CSD RefCo family AWUWIY for gabapentin hydrochloride hemihydrate. Alternatively, we can access the subsets as a search restriction after initially building a standard query. Using the Author Journal Search option, we will set up a search for a publication year of 2024. From the next menu, we select Subset from the Select Subset button and tick entries in a predefined hit list. From here, we can select the same range of subsets seen in the previous menu, and in this case we are going to select the electron diffraction subset. On completing the search, we can see that we have 170 results, and these represent structures that are electron diffraction that were published in 2024. All the other options for searching, including compound name and substructure search, can be filtered in this way, and subsets can also be specified for searches from the Combine Queries tab. Using the CSD Python API, subsets can also be chosen as the database to search. Here is a programmatic example of using the API to perform the query we just ran with the electron diffraction subset in Conquest. Conquest and the Python API are not the only way to interact with subsets. Did you know that these pre-made hit lists are also found in Mercury? If we navigate to the CSD core menu, at the bottom of this list we will find the CSD subsets. This allows the subsets to be loaded directly into Mercury and leverage the additional tools Mercury has to analyze structures. As well as subsets, we also maintain collections of structures based on chemical similarity. We refer to these as classifiers, and these are annotated during curation and are designed to aid searches where a name or diagram search alone might not find such structures. This menu can be found under the Name, Class, Query option in Conquest. We hope that you have found this video on CSD subsets helpful. Thank you for watching, and don't forget to subscribe to our YouTube channel.